This is Algebra 2, Spring Test 3 study guide. We're picking up, this is part 2, we're picking up on number 7. Tells you to factor expression, x squared plus 10x plus 21. We have to make a set of two parentheses underneath it. Then you have to factor out is ax squared plus bx plus c. You have to factor out your c value of 21. Its factors are 1 times 21 and 3 times 7. So then you have to use which pair of those numbers gets you to the b value of 10. The only one that, if we combine 1 and 21, we're either going to get 20 or we're going to get 22. The only one that works is 3 and 7. So we're going to use x times x. We're just doing FOIL backwards. And 3 and 7. Once you have your numbers, then you can put in the correct signs to go with them. Remember, the sign in front of the c value plus tells you that they're both the same sign. So they're either both going to be plus or they're both going to be minus. Since they're both the same, look at the sign in front of the b value. It's plus, they're both the same, and they're both plus. X plus 3 times x plus 7. Number 8 says solve the equation and check the solution. You have to isolate the radical, the square root of n. Don't freak out the fact that it says the square root of n and not the square root of x. Just treat it like it's any other variable. But before you do square roots and squares, you have to get rid of addition or plus 5. So subtract 5 on that side and this side as well. It leaves you with 2 equals the square root of n. If you were to write that in as a square root of x, it's not going to change it. Then in order to get n by itself, get rid of the square root of something. In order to cancel out the square root, you square it. If you square that side, you have to square the other side. 2 squared means 2 times itself twice, which is 4, is equal to n. It says and check your solution. So 7 equals the square root of 4 plus 5. Square root of 4 we know is 2 plus 5. 7 equals 7. That's a true solution. Number 9 says solve the equation and identify any extraneous solutions. Okay, your radical's already isolated on the right. Doesn't have anything and or subtracting or multiplying anything to it. So what we want to do is we want to remove that radical by, in order to undo squaring something or taking the square root of something, you square it. Square this side as well. What that gives you, I'm going to move it out here a little bit, x squared equals negative 2x plus 15. So squaring the left got rid of the radical on the right. Now we want to make this equal to 0. We don't want x squared to be a negative value. So we need to move negative 2x over and 15 over. What that leaves us with on the left is x squared. Negative 2x becomes positive 2x. And positive 15 becomes negative 15. That's equal to 0. Now what we want to do is we want to factor it out, just like we did on the other problem a minute ago. Factor out your c value 15. 1 and 15 and 3 and 5. The only pair that gets you to 2, the only pair that gets you to the b value 2 is 3 and 5. So you want to use those numbers 3 and 5. The sign in front of the c value tells you it's negative this time, unlike the last time, tells you the signs are going to be different. The sign in front of the b value tells you that the larger one is plus. 5 is larger than 3, so that one becomes plus. They're different, so x minus 3. And both of these are equal to 0. So you write it as x minus 3 equals 0 and or x plus 5 equals 0. So when you add 3 to both sides, x equals 3. And or when you subtract 5 on both sides, x equals negative 5. So both one or both of those answers could be right. That's what it means by extraneous answer. Extraneous answers will be answers that when you plug them back into the original equation give you false statements. So if we look at the first answer, x equals 3, in place of x we'll plug in 3 equals the square root of negative 2 times, in place of x again we'll plug in 3 plus 15. So 3 equals the square root of negative 6 plus 15. Negative 6 plus 15, I'm going to scroll down a little bit, is 9. So the square root of 9 equals 3. We know that 3 equals square root of 9, which is 3. So this first one checks out. When you plug in negative 5, the second answer, let's see if that one comes out right. Again, in place of x, we'll plug in negative 5 equals the square root of negative 2 times our value negative 5 plus 15. So negative 2 times negative 5 is positive 10 plus 15. The square root of that equals negative 5. So the square root of 25 equals negative 5. Look and see what we have here. We have negative 5 equals 5. But it could also be negative 5 equals the square root of 25 could also be negative 5 times negative 5. So that's going to make a true answer just like the first one. So there are no extraneous answers. X equals 3 and x equals 5. Number 10 says solve the equation by finding square roots. This one's a little bit easier. Before we get rid of squaring something, divide by 5. Do it here as well. X squared equals 15. So in order to get rid of squaring something, take the square root of it. Do it here as well. X equals the square root of 15. Number 11 says find the missing value to complete the square. We're looking for C. This says ax squared plus bx plus c. We're looking for c. In order to find c, you take b, you divide it by 2, and you square it. B's value in this case is 10. Divided by 2 is 5, and 5 squared is 25. So plus 25. Number 12 says solve the quadratic by completing the square. Okay, we want to make a perfect trinomial. This is not a perfect trinomial because we can't take the square root of 44. So we want to move that one over to the other side. It says plus 44. Let's move it across the equation and subtract it from 0. So now what you have is x squared plus 14x plus c equals 0 minus 44 is negative 44. So we want to find what plus c's value is. Again, find c just like on number 11. Take 14, take the b value, 14x, divide it by 2 and get 7, and square that. 7 squared is plus 49. If you add 49 to that side, you got to add 49 to the other side or it'll mess the balance up. So when we combine these two terms, negative 44 and 49, you get positive 5. And when you take this perfect trinomial and you make it into a binomial squared, that's what it means to complete the square. Take the square root of this and it gives you x. Take the square root of this, it gives you 7. The sign in front of b tells you plus, goes in the middle of them. So x plus 7 squared equals 5. Now what we got to do is we have to get rid of squaring something, x plus 7 squared, by taking the square root. If you take the square root of that side, you have to take the square root of this side. It'll cancel here and leave you with just x plus 7 equals the square root of 5. The only thing we have to do now is we have to get rid of plus 7 to get x by itself. Subtract 7 from this side. You can't subtract it from the square root. So x equals, let's put the negative 7 first, and then the positive square root of 5. And that's your value for x. 13 says to rewrite it in vertex form. You have to do everything you did in number 12 to complete the square, and then move one more thing over. It actually turns out to be a little bit easier. So we have to get rid of this 26 and move it to the other side. So when we subtract 26 on this side, we have y. So on the left side, we have y minus 26 equals x squared plus 12x plus c is what we need to put in, plus c. C's value again is b, which in this case our b value is 12. 12 divided by 2 squared, 6 squared plus 36. So if you add 36 to the other side, you have to add 36 to the left side. So we have 36 minus 26 on the left will give us y plus 10. Let me just combine your like terms. Equals, now we have a perfect trinomial on the right. Take the square root of the first one, it's x. Take the square root of the third one, it's 6. The sign in front of b tells you that plus goes in the middle. Almost a vertex form. The only thing we have to do from here is get y by itself by subtracting 10. Subtract 10 from the back of this equation, or this expression. y equals x plus 6 squared minus 10 is your vertex form. Number 14 is using synthetic division. Remember, for synthetic division, you want to use the opposite term of whatever that is. So it's going to be, it's -5, you want to put +5. Make sure with synthetic division that you don't skip any degrees, 4, then 3, then 2, then 1, then none. So it's good. Then write the coefficients. The coefficients, this first one is 1. Second one's 2. The next one's -23. The next one's -58. And the last one is -10. From there, bring your first one down. Don't multiply it by anything. It becomes 1. Then multiply it by the 5. 1 times 5 is 5. Combine 2 and 5 to get 7. Multiply it by 5 again. 7 times 5 is +35. Combine that with -23 to get -12. Multiply it by 5 again, and you get -60. Actually, just caught a mistake I made. Um, when you combine 35 and -23, you get +12. And when you combine that, when you multiply that again times 5, you get +60. When you combine -58 and +60, you get 2. One more time multiplied by that, you get 10. And -10 combined with 10, you get a remainder of 0. So there's no reason to write in a remainder of 0. So you have all of your values. Now what you need to do is you need to look to your first degree, x to the fourth, and start 1 degree less than x to the fourth. So the first one, 1 x to the third power plus 7 x squared plus 12 x to the first power plus 2 with no remainder because the remainder is 0. And there it is divided by x minus 5. 15 says simplify the difference. 6w squared minus, there's your key right there, 8w squared is -2w squared. Just putting your w squareds together. -8w minus 4 is -12w. And -8 minus -4. Minus a negative means plus. -8 plus 4 is -4. 16 says simplify the product. You have to distribute this. 8 times 3 is 24. And you add the exponents. 5 plus 5, 24x to the 10th. Distribute 8 times 5 and you get plus 40. You don't add x to the 5th plus y to the 3rd because they're not the same variables. You simply write it in as x to the 5th, y to the 3rd. That's all you can do with that. Do the same thing. Number 17 is a very similar problem. 6 times 4 is 24. 8 to the 4 plus 3 is 8 to the 7th. 6 times -8 is -48. Again, you have a and b, so you don't put them together. You just leave a to the 3rd and you leave b squared. Number 18 says the square root of 450 over 3. You can simplify what's underneath first and get the square root of 150. 450 divided by 3 is 150. Then you want a perfect square that goes into 150. 25 cents goes into $1.50, so 25 goes into 150. 25 is a perfect square, and there's 6 of them. There's 6 quarters in $1.50, so times 6. The square root of 25 is 5 times the square root of 6. Multiply and simplify if possible. You can multiply 35 times 5 and get a great big number, or you can use the fact that there's a factor of 5 in 35. So the square root of 5 times 7 gives you 35 times the square root of 5. And use the shortcut that tells you anytime you have the same radical multiplying by itself, you can just take that out and call it 5 times the square root of 7 and make this a much shorter problem. Number 20 tells you to multiply. It's squaring that binomial, -4 minus the square root of 5, so square it. -4 minus the square root of 5. You have to FOIL it. First terms, negative times negative is positive. Outer terms is next. Negative 4 times negative square root of 5 is positive 4 square root of 5. Inner terms is next. Negative times negative is going to be positive 4 square root of 5. And then the last terms are the ones in the back. Negative times negative is going to be positive. Again, that's just like the last problem. 5 and 5, the same one. Just pull it from under the radical. Combine your like terms here. 16 and 5 is 21. And 4 times the square root of 5 and 4 times the square root of 5 is positive 8 times the square root of 5. 21 says to graph this equation, y equals mx plus b. We did something a lot simpler earlier in the study guide. There's your b value, negative 1. Begin at negative 1. Your m value tells you where to move. It's negative 1 over 2. Negative 1 says go down. Positive 2 says go to the right. So down 1 and 2 to the right. Once you have two equations, you can draw your straight line through them. Again, try to make it as straight as you can. It makes what you're doing much, much easier. And when you do that, you have your equation that goes through both of them. And that's the end of your study guide.